On to number 4. Day 4, giant squid. You're already almost 1.5 kilometers, almost a mile, below the surface of the ocean. Already so deep that you can't see any sunlight. What you can see... Hello. If he then... Think you're a little late to this one? Well, better late than never. Soon we'll have the much coveted 500 stars and be up to date for once when the actual advent of code comes this year. Have you done all the past years yourself? Already so deep that you can't see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Maybe it wants to play bingo. Is that our first wiki link? Bingo. I've done none. Oh, okay. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random, and the chosen number is marked on all boards on which it appears. If all numbers in any row or any column of a board are marked, that board wins. Diagonals don't count. Okay. We're just gonna code bingo here. Submarine has a bingo subsystem to help passengers pass the time. It automatically generates a random order in which to draw numbers and a random set of boards. I've done some random little challenges of that sort, but they don't hold my interest too much. Okay. Yeah, out of the... past years, I think I did like 3 of them live, maybe 4. The first one I did live was 2019, like while the competition was actually happening. And there was a gap. And then I did these last recent 3, 22, 23, and 24 live. And then I went back and sort of did all the past archived ones. Yeah, that's been 1 full decade. After the first 5 numbers are drawn, there are no winners, but the board's marked as follows. Okay. At this point, the third board wins because it has at least 1 complete row or column of marked numbers. So when there's a winning board, find the sum of all unmarked numbers on that board. Then multiply that sum by the number that was just called when the board won, 24, to get the final score. Okay. So it's just a bit, well, okay, we just need we need a function to mark numbers. 0 is a number as well. We need a function to mark numbers and a function to check that all numbers have been marked. Like if we mark it, we could just change it to an X or something. Because we no longer care about the value of it once it's marked. We only care about the unmarked numbers. And then it's a case of looking for rows or columns that are all X's. Okay. Alright, so this might take a little bit more in terms of like helper method coding. We need to have... So those are the... Oh man, okay, fine. So the first line is just the numbers that are called. So that's the numbers. Then we've got blank line. So how... So we've got a blank line before each board. So... I'm trying to think what the cleanest way to do this is. Let me just see what we get here. Oh, got split. Split on comma. Oh no, not like that. Okay. Wait, what? What? Wait, why is it printing like that? 25, 29. For line in F... Oh yeah, because it's got the... Alright. Thanks for the good luck. Okay. So we need... Alright, let's just turn lines equals let's just load all those into... I just want to see that this has what I think it has. Alright, let's just do a bit of cleanup here. But we want it to be like, Yeah, that's what I want it to look like for now. Alright, so there's a blank line and then there's a bingo board. Alright, so that's how we do it. Okay. So for I in range so I think we want to take every sixth entry. So it's going to be I starts at 0, so there's just this blank one here. 1, 2, 3, 4, 5, and then it goes to 6. All right, so for each value of I is just this blank one, and we'll take we'll say a board equals like an empty list for k in range 5 board dot and it'll be lines I plus k, I plus 1 plus k. And then I think we just want a list of boards. This is the best way to store them, I guess. So that is a board. Okay, good. So we need 2 helper methods for boards. One for marking it. So define mark board with num. So given a board and a num, I want to mark that number on the board. So we just say for I in range 5, for j in range 5, if Alright, so board I j equals num. Just change it to an X. That's marks them. And this method will check if a board is a winning board. So in this case, we just need to check every... what's the cleanest way to do this one? Okay, so we say for row in board. So if we find a row where all its elements are X, then we return true. And then for column, so column for J in range 5, column we do a similar thing. We say if all x equals x for x in wait, so this time it's going to be like board ij I in range 5. I mean, we could transpose or something. That might be a cleaner way of doing it. So if all return true, yeah. Otherwise, return false. So that's how we know if a board is 1. So now we just play bingo. So for num in nums. So a number is called. We go through the boards for board in boards. First, we mark the board. Mark board with that number. If is win board then we're done. We just have to total the score. So for row in board, so if it's not an X, score plus equal X. All right. Print score. Is that what they wanted? Then multiply that sum by the number that was just called when the board won. Okay. So it'll be print score. So it'll be score and then multiply it by num. Print score. And then break out of that for loop. A cleaner way of doing this. I hate having to do those flags, if we could say. Okay, fine, do it like this. Done equals false. Alright. I mean, the first time we print it will be the answer anyway. Correct. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards a giant squid could play at once, so rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. Figure out which board will win last. Once it wins, what would its final score be? Okay. Alright, we can just be a bit, save some time here and just basically just print out every board. Okay, so... let's say we don't break out, we just keep playing bingo. But when a board wins, we just want it to, how do we... just say... so the moment it wins, score equals 0, blah, 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 print the score, print the score. Let's just change the board equals win. And then for board and boards, next time we go through the loop, if board is win, continue. So now we're just going to print all the wins of the boards in order. Well, why are we getting zeros? Oh, because it's capitals. There we go. Why are we still getting zeros? So we've changed the board to be win. So the moment a board wins, we compute the score and then just turn the board into that string. So we shouldn't ever encounter it again. Zeros are probably from... like, you can get 0. The score could be 0, or the number itself could be 0. Why there's so many? No, something's wrong. Why are there so many 1175s? Mess this up. Alright, we've been taking shortcuts. Let's just... what was it they wanted? They want the final score of the last board to win. So the first one to win was this one, 63424. See, these are all sensible numbers. Then we got these. So there's smaller numbers. That makes sense because if you keep removing numbers, so if a board is really late to win, then it's not going to have many numbers left on its board, so the numbers will get smaller. Although, why does it suddenly get bigger? Why does it follow this trend? Also, there's too many values here. Something's up. Nums. How many boards do we have? We've got 100 boards, so there should only be 100 values. Yeah, this is too many. What is going on here? I've done this in a really unclean way, though. Okay, how do we fix this? Oh, hello, iBlink. Thanks for the good luck. Alright, maybe we have to do this properly, so we just have to say, I board in enumerate boards. Alright, let's just keep track of the index of the boards so we know what. Let's just change it to, I don't know, Z or something. Z board. Print Z score. Alright, I want to see the index. See if we're repeating indices. Yeah, why are we going... So we reached 99. Why do we go back to 0? What? Board. Oh, because that doesn't do that. That doesn't change. This is just new scope. This just changes board, some variable called board, to be win. But that is not this board. This will then go into boards and find a board and call it board. So those are not the same boards. Or what we should be doing is just changing boards equals win. Change it by index. There we go. Now every board is only wins once. Hello, Quantum. Yep, that's some good coding there. When in doubt, RM, RF. Num in nums. Okay, so that's a bingo. We're basically programming bingo right now. Bingo against a giant squid. 2, 3, 5, 4, 1. Hooray! On to day 5.